Now I want to look at how do we find probabilities of a discrete random variable using its PMF, right? Because PMF lists all its values and associated probabilities. Now to find any probability concerning a discrete random variable using its PMF, just sum up the PMF over those values of x. So the key here is that whenever you want to find, right, basically probabilities concerning any discrete random variable using its PMF, we just sum up the PMF over those values of x. But let's try to understand logically why can we do that, right? Let's understand why this works. Say x can take values 1, 3, 4, and 5, right? So the possible values that here x can take are given to us 1, 2, 3, 4, 5. So these are the values x takes. And you want to find probability x is greater than 2, less than equal to 5. Now we know, given that x takes values 1 to 5, so probability x is greater than 2, less than equal to 5, it means that x takes a value 3 or 4 or 5. Now here, this or essentially means union. We know in probability and means intersection 1 means. Now probability x is 3, union x is 4, union x is 5. Now here we need to understand something, a random variable taking different values such as x is 3, x is 4, x is 5, right? A random variable taking on different individual values are mutually exclusive events, right? So x is 3, x is 4, x is and x is 5 are all mutually exclusive events, right? Because we know when we perform a random experiment, we know you get exactly one and only one out. So you only get one value, the random variable corresponding to that particular out. Right? So we know over here that the random variable taking on these different individual values are mutually exclusive events. And we know the probability of union of mutually exclusive events is the sum of their individual probabilities, right? This is exemption probability. So that's why this union can be written as sum of individual probabilities because of the fact that these are all mutually exclusive events, right? So this is why. So when I wanted to find probability x is greater than 2, less than equal to 5, like we discussed right now, to find any probability concerning a discrete random variable using its PMF, just sum up the PMF over those values of x, right? So what I would have done is I would have just summed up the PMF over the value over those values of x. So probability x is greater than 2, less than equal to 5 would mean I would sum up the PMF for x is 3, 4, 5, which is what we're doing over here. But we understood the logic behind summing this up, right? The logic comes from the fact that here we can write this as probability x is 3 or 4 or 5 or means union. And since random variable taking on different individual values are mutually exclusive events, the probability of the union is the sum of the individual probabilities. So this is why the idea of summing up both. So this is just the logic. So why we can sum up probabilities of a discrete random variable using its PMF to find any relevant probability amount. So two things that we should keep in mind when finding probabilities of a discrete random variable using this PMF. The first thing we should always keep in mind the values the discrete random variable takes, right? So whenever you're finding it, you need to keep in mind it. If we go back here, we need to know that x greater than 2 less than equal to 5, what values come under this? We needed to know the values the discrete random variable takes are this for me to identify, okay, here x could be 3 or 4 or 5. So you should always keep in mind the values the discrete random variable takes and always check if probability of complement is easier to find, right? So the two things that we should keep in mind. Number one, that we should always keep in mind the values of that particular discrete random variable takes, and we should check if it's easier to find the probability of complement. Let's look at an example related to this now. So let's look at this example. Okay, so now we're going to look at this. So, so we have x and here we have probability x. Right, so these are the probabilities x takes each of these values. So here x takes value 1, 2, 3, 4, and 5. It takes value 1 with probability 0.2, value 2 with probability 0.1, value 3 with probability 0.2, value 4 with probability 0.1 in this one. Yeah, so this. Now let's do part A. Part A is find the probability x is greater than 2, less than equal to 5. Let's want to find this probability. So we know that probability x is greater than 2, less than equal to 5. Now keeping in mind the values the discrete random variable takes, this can be this can be probability x is 3, 4, or 5. So this is the probability x is 3, or x is 4, or x is 5. And we know, so we're understanding the logic behind it, although we know Okay, we can just simply find this probability by summing up the PMF for those values of x. X is greater than 2, less than equal to 5 means x is 3, 4, or 5. So I can just sum up the PMF over these values, right? So I can do probability x is 3 plus probability x is 4 plus probability x is 5. But let's try to understand the logic. So this means probability x is 3 or 4 or 5. We know or means union. So we can write this as probability x is 3, union x is 4, union x is 5. And we know since each of these are mutually exclusive elements, the random variable taking on different individual values, probability of the union is the sum of the individual properties. So we did eventually do that. Now we did sum of the PMF of those values of x, but we're trying to understand the logic there. Since mutually exclusive. Right, in the end, we did do the same thing, right? Okay, we did sum up the joint, like we talked about this. Okay, when you want to find, again, go back, like we talked about over here, to find any probability concerning a discrete random variable using its PMF, just sum up the PMF over those values of x. That's what we exactly did over here. That to find this probability that x is greater than 2, less than equal to 5, which means the probability x is 3 or 4 or 5, we just eventually did sum up the PMF over those values of x, right? So we did sum of the PMF over 0 0.2, 0 0.10, right? So this is, sorry, so this is 0 0.2 plus 0 0.1 plus 0 0.4. So this is 0 0.7. So what if now we wanted to find the probability x is greater than 3? So let's just clear, okay, let's not clear this up, we can do it. Let me just clear this much up and write this again. So x3, sorry, x3, 4, 5, right? So x3 is 0 0.2, x4 is 0 0.1, x5 is 0. Right, so now let's say we wanted to find probability x is greater than, again, to if I go back, to find probability x is greater than 3, we know we can just sum up the PMF for those values of x. So that means that over there the values are 4 and 5, so we can just sum up the PMF values 0 0.1 plus 0 0.4, right? So that means whenever we want to find probability of any discrete random variable, again going back to this, just sum up the PMF over those values of x, right? So we can't just sum up the PMF over these values of x, so we can just sum up probability of x is 4 and probability x is 4. But let's again try to understand more logically. So provide the summing of word, probability x is 4 or x is 5. Sorry, this is 4 or x is 5. Right, so now or we know means union, just like and means intersection. So I can write this as probability x is 4 union x is 5. Right, and we know the random variable taking on these different individual values are mutually exclusive events, and probability union of mutually exclusive events is sum of the individual probabilities, right? Since mutually exclusive. Right, so that's why eventually we saw it, we did eventually just sum it up, right? But then going back, like we said, you just sum up probability x is focus on probability x 5, but you try to understand logically why we're doing that. So this is just equal to 0 0.1 plus 0 0.4 is 0 0.5, right? So now going back to probability x is greater than equal to 3. Now this is essentially just probability x is 3. Again, if we go back to just this, now this was probability x is greater than 3. When you're finding probability x is greater than 3, this is different from this part, because now this involves the probability x is 3 also, right? So now we'll just sum up the joint PMF over these values of x, right? So probability x is greater than equal to 3 means that it can be 3, 4, 5. We can just sum up the PMF over these values of x to find this probability. Let's understand it again logically. So difference between part C and part B is that in part B, you wanted to find probability x is greater than 3. Now you want to find probability x is greater than 3. This is probability x is 3 or x is 4 or x is 4. Like we discussed, if logically you want to understand or means union, right? And here, note, this is the same as part A actually, right? So over here, we don't have to actually solve this again. We could No, this is as part A. Like if we go back, so in part A, we essentially found the same thing. Probability x is 3 or x is 4 or x is 5, right? By summing up, and eventually all this just boils down to summing up the probability x is 3 plus probability x is 4 plus probability x is 5. So since this is the exact same as part A, so we don't have to do this again. So probability x is greater than equal to 3 is just probability x is greater than 2 less than equal to 5, like we had in part A, which is just 0.7. So basically part A and part C are looking at the same thing, or just different ways of seeing the same thing. So probability x is greater than 2 less than equal to 5. Here's the same as probability x is greater than 3. Let's do the last part. Probability x is less than equal. Now here we're gonna use the packet. We're gonna use the complement rule to do this, right? So the complement rule tells us this is the same as 1 minus probability x is greater than 4, right? Because what is the complement rule? The complement rule tells us probability of A is 1 minus probability naught. Right, so probability x less than equal to 4 is 1 minus probability x is greater than 4. And we'll look at why did we use the complement rule here. So now again, here it's important to keep in mind values the discrete random variable takes, right? So it's like over here, when we had to find probability x is greater than 3, we knew it only meant probability x is 4 or x is 5. Right? We knew it only meant that x can be 4 or x can be 5. Because we knew the values it took, right? We knew it can only 4 or 5. Similarly, probability x is greater than equal to 3. We knew it only be 3, 4, 5 because it only takes 5. So it's always important to keep in mind the values that is given. So probability x is greater than 4. So when x is greater than 4, over here there's only one possible value. Over here there's only one possible value, 5, right? So when your probability x is greater than 4, we can see there's only one possible value, 5. So again, it's important to keep in mind the values of discrete random. For this discrete random variable, probability x is greater than 4 just corresponds to probability x is 5, which is 0.4. So this is 0.6. Now here we use the complement rule. Alternatively, we could have also done this without the complement rule. Alternatively, we could do 4 as probability x is 1. Again, x is less than equal to 4. We could have found, we know x less than equal to 4 means that it's 1, 2, 3, or 4, right? Given the values it is trying to take. So it's important to keep in mind the values it takes. For us to know what does probability x is greater than 3 mean? What does probability x is greater than 4 mean, right? We know given this random variable in the value takes, x is greater than 3 means that it can be 3. Again, if we go back, it means that it can be 3, 4, or 5. Greater than 4 means that it can only be 5. So this is keep in mind the values it takes. Alternatively, we could do probability x is less than equal to 4 as probability x is 1 or x is 2 or x is 3 or x is 4, right? You could find it like this, but this is a relatively longer approach. If we could sum up the PMF, so better to use complement. Right, so we know over here that probability x is less than equal to 4 means the probability x is 4, 3, 2, or 1, right? We could just sum up the PMF over those values, but the last part and answer would happen the same, right? Because probability x is less than equal to 4 means x can take a value 4, 3, 2, 1, and we can sum up the PMF over those values, right? This would give us the exact same answer. But alternatively, we could use the complement rule because probability x less than equal to 4 is 1 minus probability x is greater than 4, and x greater than 4 is just one probability, which is 5 here. Right, so in that sense, so whenever you're finding probabilities of a discrete random variable using its PMF, like we said, you just sum up the PMF over those values of x, and you understood the logic behind it as well. And always keep in mind the values it takes, because for me to identify x greater than 3 means the values can be 4 or 5. I need to know what values it takes. X greater than equal to 3 means it can be 3, 4, or 5. Similarly, for me to identify x greater than 4 means that it can take a value 5. We need to keep in mind the values it takes. So we should always keep in mind what values it takes and see if it's easier to use the complement.